The interesting thing is that here we are right now, about 35,000 years ago, 25 or 30,000 years ago, it started heating up. And when it heats up, it goes pretty fast. And it's heating up, and here we are today. It bounces around for a while. And so, anytime the peak is high, we have an interglacial period, and that's what we're in right now. We're in an interglacial period. We know in the past it has been colder, in the past it has been warmer. And we are continuing that cycle. The question, of course, is why does this happen? The answer, of course, is I don't know. And I don't think anyone does. What causes these, but you see that they're fairly regular intervals, and we just need to do a little bit more study. The problem is that it's really hard to tell what's going on. When I was in elementary school, they didn't have oxygen isotopes. They couldn't even pronounce the word. And they looked at evidence, physical evidence on the landscape. And they said, well, here's a glacier. Oh, look, here was another glacier and another. And so they figured out that there were 4 glacial periods. The problem with glaciers, of course, is that when they come through, they scoop away everything that was there before, and they deposit new stuff. So how can you tell? Well, the isotopes help, and also looking at the evidence they leave behind helps too. Looking at the more recent past, this is what North America looked like during the last glacial period. All of this was frozen. Greenland is here. This Cordilleran ice sheet is very interesting. If you've ever been to the Athabasca Glacier, the Columbia ice field in Canada, this is the remnants of that. Many of the glaciers that we will see coming down into the water are remnants of this Cordilleran ice sheet. And this is what our world looked like, and North America looked like, about 15,000 years ago. Notice that not all of Alaska and Canada here was glaciated. There's the Yukon River, which made very important for a path for migration of people and animals. Also very important for gold prospectors and copper deposit explorers like what I was doing, because this area was not affected by a glacier. The ground wasn't scooped away. And so this is a great place to look for gold, and in fact, on Friday or Saturday, I don't know, the last talk will be on the Yukon Gold Rush, and you'll see what happened up in this area. Well, now, however, the glaciers are gone. The big continental ice sheet. So there's one up here in Greenland. Of course, Antarctica is one huge, big ice sheet. And otherwise, the glaciers are just these little patches here. There's the Columbia ice field. Here's glaciers around the coast of Alaska. And most of these are alpine glaciers. Continental ice sheets we're not going to talk about. We're not going to Greenland, I hope. And Antarctica, we're not going there either, but wouldn't that be fun to go at some time? So we're going to talk about the alpine glaciers, the ones that are in the mountains, and the ones that are pretty much what we see today. And I think all of us would agree, this is glacier country. I mean, I can almost hear the yodelers and see the mountain climbers on this, even though this is in Washington, this is not right here. And so we think we know what a glacier looks like. How about this? This is, oops, go back. This is a forest, a jungle, a rainforest of trees and ferns and very nice areas. And we were walking along here. We walked for about an hour through an absolute rainforest, came around a corner, and this is what we saw, the beautiful Fox Glacier in New Zealand. And interestingly, think about it, it takes a rainforest or a very wet climate to make a glacier. And so think about Mount Olympus in Washington State, the Olympics. There's 7 or 8 glaciers on those mountains. Right down at the bottom is the Hoh rainforest, one of the wettest places in North America. And so you need to have wet, you need to have cold, and the cold is found either by making elevation, high elevation, or high latitude. And that's where we find the glaciers today. For Alaska, these glaciers fall into the category of mostly high latitude, the ones that we're going to be seeing here. They are only probably 3,000 or 4,000 feet above sea level, which would be nothing. Some of you live at 4,000 feet above sea level. But here in Alaska, because our latitude is so high, that we have some glaciers. So let's take a look. Numerous types of glaciers. They are, this is the foot end, the terminal end of the Mendenhall Glacier, which you'll see when you go to Juneau. And glaciers start up high, make their way down low. Do they move? Yes, they move in the same way an escalator moves, moving stairway. You get on at the top, so a rock falls in up here. You ride the stairs down. You get to the bottom, the stairs disappear. And they reappear at the top. It's magic. And same with this. It's always being replenished with snow up here at the top. It moves down under its own weight into the middle, and it ends someplace where the ice starts melting. But it's always moving. The snow and the ice is always moving. Let's start at the top of the escalator and ride down and see what it looks like. This is the top, the head of the Fox Glacier in New Zealand. And you can see the amount of snow that's here. It's very thick at this point. The glaciers usually start in a valley, a natural valley between peaks. And while they are there, they're carving out. They're plucking rocks out of the bottom. They're making a big bowl-shaped area for them to sit in. And these mountain peaks over here are caused by the glacier. And ice wedging causes the rocks to crack and to fall off and into the glacier. And as they do, they carve these mountain peaks into what are called aretes, A-R-E-T-E-S, or horns. And you can remember that. This is a very famous horn. In fact, it's so famous that this matters. It's the Matterhorn, that's right. And so this one had glaciers on 4 sides of it. It's actually pretty unusual to see that. So this is what happens at the top of the glacier. And as these rocks get pulled off, they fall into the ice. And they make these lines called moraines. This is a debris trail of rock and dirt and stuff that falls off these mountain peaks. You have a moraine that goes down the middle, that's a medial moraine. You have a moraine that goes down the sides, that's a lateral moraine. And the longer the glacier's there, the more stuff falls into it and is brought down by gravity and by the ice melting and freezing again. And you see these in active glaciers. There's a nice medial moraine through here. But when you get to the bottom, the glacier starts melting. And at some point, it's going to melt and bring down all of that stuff that's had in it, all of the debris, the rocks and everything. And so right along here, you're going to get another moraine made. We call that a terminal moraine, actually. Here's part of it here, and the glacier has receded back. Again, this is Mendenhall. They have a wonderful visitor center there. If you can go to this one, by all means do. Are any of you doing like a helicopter flight to be on a glacier? Oh, that's wonderful. Wonderful. Here, let me tell you what to do. take a penny, don't even see you do this, put it in the snow, and 400 years from now, come back, and you'll be able to get that penny, it'll probably be worth something by that time.